All right, so the second rule of proving identities is never cross an equal sign. Why is that? Well, when you solve an equation, you can cross an equal sign because you know it's true. All right, but we're trying to prove something is true, so you can't assume both sides are equal. Therefore, you can't cross the equal sign. You can't assume what we're trying to prove. So when we're trying to prove the tangent of x is equal to the cosecant, the tangent of x times the cosecant of x is equal to the secant of x, we can't like divide both sides by tangent or divide both sides by cosecant. Instead, we're going to try to make the left side look like the right side. So the way you do that is you use your 8 fundamental identities. So usually you want to keep things in terms of sine, cosine, and tangent, or sine and cosine more specifically, and that's one of the guidelines that we'll go over. So the first thing I'm going to do is take cosecant and write that as 1 over the sine of x. All right, and then you know what? I'll also take the tangent of x and rewrite that as the sine over cosine. Sine of x over the cosine of x. All right, and then the right side I'm not going to touch. I'm going to try to prove that the left side equals the right side. So I'm trying to get this to simplify down to secant. So does anyone see what we could do to help us make the left side look more like the right side?
You could cancel out the signs.
Oh yes, you can cancel them out, the signs. Very good. And then you get 1 over cosine of x, which is equal to the secant of x. And now we just proved that tangent of x times the cosecant of x is equal to the secant of x. All right, and we didn't have to cross an equal sign. We didn't have to divide both sides by cosecant. We didn't have to multiply both sides by cosine. All right, and you're not allowed to do that, so don't do it. All right? Okay, so the next rule of proving identities is if you have a fraction, try to break it up into 2 smaller fractions. So if we look at this, another rule that I'm going to give you, guideline, is always start on the more complicated side, because it's easier to take something that's really complicated and simplify it down than to take something that's simpler, like the right side of this identity, and make it more complicated like the left side. All right, so if you ever have so I'm going to start on the left side. And if you ever have a fraction, you can break it up if there's a sum in the numerator, right? If I said 1 plus 1 over 2, all right, that's the same thing as 1/2 plus 1/2, all right? Because, you know, you're going to divide before you add. So you could divide 1 by 2, divide 1 by 2, and then add the 2, all right? So you don't have to do that, but if you notice, the right side has 2 terms. Terms are things being added. The left side has 1 term. So by breaking up the left side into 2 fractions, we're making it less complicated. Sorry, take that back. We're making it look more like the right side. Okay, so break this up as the sine of x over the sine of x times the cosine of x plus the cosine of x over the sine of x times the cosine of x. All right, so I'm not even going to rewrite this because I'm trying to get that to look like that. Now, does anyone see what we could do next?
Yeah, you can first start by simplifying the first part to 1 over the cosine of x, and then you can simplify the second part to 1 over sine.
Very good. So the left side, you could cancel out the signs, make it 1 over cosine. The right side, you can simplify it and make it 1 over sine. All right, so now we have 1 over cosine plus 1 over sine. And would you look at that? 1 over cosine is equal to the secant of x plus 1 over sine is equal to the cosecant of x, because they are reciprocals. All right, and then we want to make this look exactly like the right side. So you really should rearrange this because you can add in any order, the commutative property of addition. All right, and now we have it looking like the right side. All right, so you can't assume anything. You can't assume that the person knows that you can add in any order. So you got to make it look exactly like the right side. So there you go. So that was 1 step, 2 steps, and 3 steps. And honestly, if you stopped at the second step, I personally wouldn't take off, but I should because I should hold you to the highest standard. All right, so there you go. So when you have a fraction and a sum in the numerator, try to break it up, especially if the other side of the equation has two terms to it. All right. Okay. Whoops. Okay. So it's usually better to start on the more complicated side. So what do we think? Right in the chat right now, do you think the left side is more complicated or the right side is more complicated? Type in the chat your thoughts. Should we start on the left, right, left if we should start on the left side, right, right if you think we should start on the right side? Nice. Love the participation. Everyone's going with right. So let's start with the right. I love it. All right, anyone have an idea on what we could do on the right side?
You could split the terms again.
Yeah, separate them into two terms again. Very good. So you could break this up as 1 over the sine of x plus cosine over the sine of x. Very good. Now, anything that we could do there to help it look more like cosecant of x plus cotangent of x?
You can convert 1 over the sine of x into cosecant of x.
Very good. So at this point, you're just looking at your fundamental identities and you're being like, does 1 over the sine of x equal something else? Yeah, it's the cosecant of x. Cosine of x over the sine of x is equal to the cotangent of x. All right? Bada bing, bada boom. That's it. We're done. All right? And that's the main gist of these proving identities. And if you enjoy this, that's great. That probably means you might be a math teacher one day. If you hate this, then I'm sorry. It's going to be a long week. But it is a good mental exercise. I think you'll like struggling with these as you get more practice with them. But when you get stuck, look to these rules to help guide you out of it. But there's never like a 1, 2, 3, formula for doing these. Everyone's different, and you just gotta use guidelines to help you. All right, number 5. Try adding and subtracting fractions by getting a common denominator. All right, so we just talked about pulling fractions apart in this guideline. All right, because on the right side, we had 2 things being added. On the left side, we had just 1 thing. So we broke it up into 2 things being added to make it look more like the right side. Okay, here we have on the left side 2 things being added. And then on the right side, we have 2 things being multiplied together. So if we could, now you might be saying, starting the more complicated side, you could make an argument that that side's more complicated. They're both kind of equally complicated in my opinion, which is why these are guidelines. But the way I look at this is if I could somehow add these 2 together and make it like 1 term, like this is 1 term, terms are being added, so that's only 1 thing, 1 with 2 factors, then it will have to simplify this or else it's not a true identity. And I'll never intentionally give you an identity that's false. So that's something you could do to help yourself. If you know that the left side equals the right side, do whatever you can to make the left side look like the right side, as long as it's legal, like multiplying by 1 or adding like terms or so on and so forth, or substituting something that's equal to something else. And it should naturally simplify to this. So how are we going to add those together? Well, another guideline that we'll learn is when you're stuck, put everything in terms of sine and cosine, because tangent, cotangent, secant, and cosecant all could be expressed in terms of sine or cosine. So tangent would be the sine of x over the cosine of x, and cotangent would be the cosine of x over the sine of x. Okay, now we could get a common denominator, and we can multiply this by the sine of x over the sine of x, and multiply this by the cosine of x over the cosine of x. All right, we're allowed to do that because that's a form of 1, and 1 times anything is itself, so it's not changing the value. Okay, now the denominators are the same. They're just multiplied in different orders, so we can write it as sine of x times the cosine of x. All right, the numerators Sine times sine is sine squared. So sine times sine we could write as sine squared of x plus, and then cosine times cosine is the cosine squared of x. All right, nice. So now we just have one term. I know there's something being added here, but it's all over the same denominator. So this whole thing in the blue box should simplify to that, or else the identity is not true. So does anyone see anything that we could substitute in here to help us maybe get it closer to secant of x times cosecant of x? And I actually wouldn't worry about like that. I would just think, I would look at this and say, is there anything that I could substitute for something? Now think back to your 8 fundamental identities. If you have your notes, look back at your 8 fundamental identities and see if you notice any of those here.
So you know the top, the numerator equals 1.
Very good. The numerator equals 1. Nice. So let's substitute it in. And if it doesn't work, then we just delete that step and go back. But let me give you another word of advice, and I'm not even sure if it's a guideline, but it should be if it's not. Anytime you see a trig function squared, sine squared, cosine squared, tangent squared, cotangent squared, secant squared, cosecant squared, you could substitute something in for either the sum of these two all together or just for one of the terms. All right, so anytime you have a trig function squared, look to the Pythagorean identities, and I'd say 95% of the time, that's what you need to do. You need to substitute something in for either sine squared, cosine squared, or the sum of both of those. All right, so if you saw like, let's see, cosine. So if you saw like tangent squared plus 1, you could substitute in secant squared. Or vice versa. You see secant squared, you could substitute in tangent squared plus 1. All right. So that becomes 1 over the sine of x times the cosine of x. Okay. And if we look at what we're trying to prove, we're trying to prove that that's equal to the secant of x times the cosecant of x. Now what we could do, and this is kind of weird, but you could do it, you're allowed to, you can kind of write this as 2 factors, because like 1 times 1 is 1. Like every number has a factor of 1. So you could break this up as 1 over the sine of x times 1 over the cosine of x. Think of it like that. And then, now substitute. 1 over sine of x is the cosecant of x. 1 over cosine of x is equal to the secant of x. And that's pretty much it. The only thing we have to do now is just rewrite this in the other order so it look exactly like the other side. And there we go. So I know I'm kind of zigzagging all over the place because, I'm kind of limited on space here. But if we go back to the top, the first thing we did here is we broke up tangent and cotangent. Well, we didn't, it was already broken up. We wrote it as sine over cosine plus cosine over sine. Then we got a common denominator by multiplying by sine over sine and cosine over cosine. Then we wrote it over one denominator. Then we simplified it by plugging 1 in for sine squared plus cosine squared. And then broke it up and then substituted. Cool. Any questions? All right. All right. Number 5. Try adding and subtracting fractions by getting the common denominator. So we learned in a previous step that if we saw a fraction like this, that we could break it up into 2 fractions. Now, I'm not going to say that we're going to do that here, but just reviewing a possible pathway towards getting the right answer. All right, so that's one way we could approach this problem. Oh, this is the same rule. This is just another one. So why don't you guys try this one? Let me give you like a couple minutes to play around with this one. And then I'll show you how I did it. And then you guys could tell me how you did it. So I'm going to stop the recording. And you have two options here. You could do this, or you can take this and try to get a common denominator and go about it that way. All right. So I'm going to pause the video, give you, it's 2:08. I'll give you till like 2:13 to struggle with this for 5 minutes. All right, then we'll talk about it. Okay. So we're going to start on the left side here because that's what the people voted. And the left side has two fractions. The right side has one fraction. So in order to get the left side to look like the right side, I want to combine these fractions. So I'm going to multiply the left side, the first term, by secant over secant. And that becomes secant squared of x over secant of x times the sine of x. And then over on the right side, I'm going to multiply by the sine of x over the sine of x. All right? So that becomes minus the sine of x over the secant of x times the sine of x. Sorry, sine of x squared, because it's sine times sine, sine squared, over secant times sine. All right, cool. Now we look at the right side, and we see, all right, what could we do to make this look more like that? Now the denominator on the right is tangent. So let's see if this denominator is also tangent. Well, secant, now if I had more room on my paper, I would just like rewrite this entire step. But because I don't have room, I'm going to do some work and then erase it. You should not do that. You should write out every step. All right, I'm just doing it because I don't have paper. Secant is equal to 1 over cosine of x, and sine is equal to sine. So that becomes sine of x over cosine of x, which is equal to the tangent of x. All right, so in my next step, I could just replace this with the tangent of x. So again, if you were doing this on paper, you should write that out in more than one step, but you shouldn't assume too much. So I'm going to go up here so we have space. So I have secant squared of x minus the sine squared of x over secant times sine, which is tangent. Okay? Now we compare these sides, and we got the denominators are the same on both sides. The numerators are different. So, but they should be equal, or else this identity is not true, right? If I said like 5 over 10 is equal to blank over 10, you don't have to do any cross multiplying. You know that this should equal that because the denominators are equal. So this should equal that. Now that's not a proof, but you should think about that and be like, all right, I'm just going to work with the tops now and try to prove that tangent squared plus cosine squared equals secant squared minus sine squared. So remember, when you have trig functions squared, you should look to the Pythagorean identities, all right? So we know that tangent squared of x plus 1 is equal to the secant squared of x. So I could substitute that right in there, all right? So I can replace that with tangent squared of x plus 1, okay? And I know that sine squared plus cosine squared equals 1. Now this right here is really like 3 identities. It's sine squared plus cosine squared equals 1. It's sine squared equals 1 minus cosine squared. It's cosine squared equals 1 minus sine squared. So when you see just sine squared, you could replace that with 1 minus cosine squared. And you might be saying, well, you just crossed an equal sign, Mr. Skev. What the heck? You told us you couldn't do that. Well, that's only when you don't know the identity is true. And the fundamental identities, you're allowed to assume they're true. So you can manipulate them if you'd like. All right, so bang, sine squared equals 1 minus cosine squared. So now I'm going to substitute that in, and you have to be careful with parentheses here. So it's going to be minus sine squared, and sine squared is 1 minus cosine squared. All right, and that's all over tangent of x. All right, now we distribute the negative, okay? This becomes a -1. That becomes a positive cosine. The ones cancel out. And again, you should write these out in multiple steps, but I'm just, do as I say, not as I do. And I'm only cheating myself here because I don't have room. But bang, we're done. All right. And guys, this is not easy. This is a challenging thing. It's not a 1, 2, 3 step process. It's different every time. So don't get discouraged. We're going to take time with this. Just keep, whenever you get stuck, go back to these guidelines and identity and fundamental identities and play around with it. And a lot of times you're going to go down a path and it's not going to work, and you have to go back and start again. All right. But that's a great life lesson. All right. Sometimes you got to do that. And sometimes you're just sitting at practice and you get on Google Maps. Sometimes things go your way, but when they don't, you got to be persistent. All right. So I'm going to call it a video. And we'll pick up with this next class.